Okay, hi guys, I'm Mike Kolesnik. With me is Josh Hershberg. We work at Red Hat, we work on the OpenDaylight project. I'm going to talk to you about OpenDaylight, specifically Netvirt, which is a project inside OpenDaylight, and how it integrates with OpenStack's Neutron. So if you have any questions, please keep them to the end and we'll try to answer them as best as we can. Okay, so quick agenda. First, we'll do a short introduction of what is OpenDaylight. Then we'll talk about the architecture between them, go over a high-level architectural overview of how they integrate with each other. And then we talk about the Neutron drivers and the approach that we've taken in OpenDaylight to solve some issues there. And we'll do an OpenDaylight Netvirt deep dive. Okay, so first, a short introduction to what is OpenDaylight. So basically, OpenDaylight, if you don't know already, is an open source SDN platform. It's a very big project under the Linux Foundation umbrella. It has more than 1,000 contributors, hundreds of companies, about 4 million lines of code, and several dozens of downstream products that derive from it. And basically, Josh is going to deep dive a bit into OpenDaylight and introduce it.
There we go. So probably the single most important fact about OpenDaylight is that it's a platform. It's not a tool for doing any single kind of networking, but it's a generic SDN platform. It supports many, many protocols. You can add protocols support to it. It's a very, very large community, and it's not really ready for future innovation. There's constantly new projects and all kinds of stuff popping up over there, always sort of expanding. Next slide. We're having difficulties. So, and we'll talk about this a few times throughout this talk, but basically the core of OpenDaylight revolves around a sort of netconf kind of configuration data, which is then exposed over also RESTconf, and it's modeled with the Yang modeling language. All these things are sort of interchangeable and model this kind of like hierarchical tree structure of data. And it's all open. You can look at any of the data through these APIs. And the idea, that's at the core. And then on the northbound and southbound, there are all kinds of different standard interfaces and protocols. And in the middle, obviously, you have all the business logic and applications that manage different networking features. There are, for the Neutron implementation, the implementation of the Neutron networking, there are no agents on the host. It's pure OpenVSwitch. And there's also, because of that, no lock-in to any kind of operating system features or anything that you have with the the standard ML2 plugin. Okay, next slide. OpenDaylight also has other features not part of the Netvirt project for topology discovery and all kinds of automation features, monitoring and troubleshooting, all kinds of stuff that you would want in an SDN platform. It's all in there. And it also has sort of the basic kind of features that you would expect in any kind of cloud platform, a multi-tenancy, and does the whole network stack and security, all that. And most importantly, I think, or very importantly, it supports a lot of NFV kind of use cases. So because everything is OVS, so it's easy to support DPDK. We'll talk, there are future plans to support other data planes. There's a project now to do SFC, service function chaining. And there are various service provider applications that you can plug into this platform. Okay, next slide. So this is the architecture. This should be a scary slide, I know. But the basic idea of OpenDaylight is, at the very core of this, is this thing called the service abstraction layer. That's if the whole thing is data driven, model driven, this is the model. And below that, you have the data plane. And here you can see there's an OpenVSwitch, OpenFlow-enabled devices. Usually those two things go together, though not necessarily. And all kinds of other stuff. And there can be physical stuff down here also. We support hardware VTAP and all kinds of other stuff like that. And basically, this model is then exposed northbound through various kinds of REST APIs and netconf. And these guys are the specific models, I guess is what you would call them. And then on top of all this, you get the application. So Netvirt would be one of those. Netvirt is the Neutron. That's what we're talking about. That's the Neutron implementation. And it has a pretty cool graphical user interface. I've actually only seen it once because I don't do anything with it, but it's pretty cool. And that's the basic architecture. And the next slide I'll show a little bit more in depth. So this is the Netvirt component. If this is OpenDaylight, so this is the service abstraction layer. That's the data-driven, the model. And there's a component called Netvirt that's responsible for taking the data that comes in from the Neutron northbound. So if you create a network or a subnet or a port or whatever in Neutron, Netvirt will take that and translate it into the various OVSDB and OpenFlow models that then get translated and pushed down to OpenVSwitch, also hardware gateway, which is an OVSDB application and not a OpenFlow application. And that's the basic architecture. And we'll get more into the technical nitty-gritty. Next, Mike is going to talk about sort of this quadrant, how Neutron itself talks to and works together with Netvirt. There are plans in the future to support VPP. That's the FDIO, which I have on good authority is actually supposed to be pronounced FIDO, but everybody pronounces it FDIO. And the idea is to plug that in down here somewhere. For now, we're not doing anything with that, but that's for the future.
Okay, so this is a high-level overview of the integration itself with Neutron. Back one slide. Okay, so on the left we have the OpenStack controller node. Obviously, we have the normal services like Nova, Keystone, etc. running on it. And if we look at inside Neutron, we have the ODL L3 plugin, basically because L3 currently doesn't have like extensible mechanism like the ML2. So we have a different plugin for ODL. And inside ML2, we have all sorts of plugins. So basically the normal L2 plugin, and then all sorts of other plugins to provide the advanced functionality like BGP VPN, trunk ports, quality of service, all those API extensions. And then we have this journal thread. We'll talk about it in a second. And also down here, we have the DHCP agent and metadata agent. So they're kind of optional because you can receive DHCP from OpenDaylight. So OpenDaylight could do the IPAM for you. But then it won't currently provide metadata support. So if you want metadata support, you have to deploy these. But again, you only deploy these on the controller nodes. And then if we look what's happening from Neutron in terms of database writes and reads, so Neutron, basically the plugins write the resources to the Neutron DB. And we said we have some journaling part. So each plugin writes the journal entry. And there's an ODL journal thread. We'll see in a second how exactly it works. This runs and reads these journal entries and then calls the REST API over to OpenDaylight, right? So on OpenDaylight node, we have basically OpenDaylight, which is a carafe, which is an application container. And then inside, we have the applications of Netvirt, Neutron, which are basically providing the Neutron functionality that we want, like L2, L3, all the extensions are provided via Netvirt and Neutron. So Neutron is more like just the REST API, right? And Netvirt is the heart of all of this. And we have other applications like the OpenFlow plugin and OVSDB, which each one talks with the appropriate protocol with the OpenVSwitch running on the compute node. So as you can see, we don't have any special agent running on the compute node, just OpenVSwitch, plain old OpenVSwitch. And obviously you have like a Nova Compute agent, maybe some other OpenStack related agents, but nothing new networking specific. Right, so let's talk about how this integration takes place. And to understand the integration and its current state, you need to first understand what happened at the first time we tried it. So first implementation was the V1 driver, we call it, which was a naive implementation. So just an example here of how it worked. We have the create network arriving through the internet. We have like the request from the end user. And it arrives to the control node, to Neutron. And basically the ML2 plugin takes it and writes it to the database. And then via hook point, it calls this networking ODL part, which basically is the driver for OpenDaylight. And this driver just calls OpenDaylight directly, calls the Neutron, and everything starts to roll from there. So very simple model, very simple design. The problem with that was it's basically very raceful, because you could have like several operations on the same resource happening in an AJ environment. So basically, you could like have several updates on the same port, for example, and then these updates could override each other. So it didn't have any ordering happening. And also if you have some dependent resources like a port and the subnet, for example, so it could be possible that the create port could be sent to OpenDaylight before the create subnet. So obviously that's not very good. So what we did, we came up like networking ODL community, which is very, very small, came up with this model of the journaling. So what we have instead of just direct call, we have again the request arriving at Neutron, and the ML2 plugin, as it was, it writes the resource to the database. But then what happens, the networking ODL part, it doesn't call directly to OpenDaylight, but it writes the request to a journal table. And from this journal table, then the journal thread we saw earlier reads all the requests and processes them and sends them off to OpenDaylight, right? So this introduces another step, another bit of complexity, but it also allows us to fix the things we talked about earlier, the problems. So if we can look at the benefits there. So basically it's asynchronous now. So if you have a request arriving to Neutron, it's not sent to OpenDaylight immediately, but it just gets written and it will be eventually handled. So it frees up Neutron faster. So from a certain perspective, that's better. And it basically fits ODL's general design paradigm, because ODL itself is asynchronous. So that means if I now run a create port on ODL and I get a 200 success code, then it doesn't mean this create port happened. Okay, it doesn't mean the port was created. It just means that, okay, ODL received your request and sometime the port will be created for you. Okay, so that's like the general paradigm and it fits this paradigm. And what it's mostly allowed us to do is introduce order and dependency checking. So basically, if you have the operation on the same resource, let's say if you have like create port and then update port and another update port and then delete port, then they would happen in the correct order. So you don't have like two conflicting updates that just are raceful or anything like that. And also we have like dependent resources handled. So if you have like a network and a subnet and port, then they all get handled in the correct order. And for supporting AJ environments, we have some sort of DB level locking. Okay, so this allows us to obviously scale out, add more resources to add more servers to the pool. Okay. And the features, obviously we have the basic features covered, so it's L2, L3, which is distributed by default. There's no like single network node, so that's another benefit of OpenDaylight. And all the accompanying features like security groups, floating IPs, SNAT, and whatnot that exist in the basic layer 2, layer 3 connectivity. Also, we have the more advanced features, and this list keeps growing. So we have the BGP and L2 gateways and trunk ports, and each version new features are added, it mostly depends on the availability in OpenDaylight, right? So OpenDaylight is, if it's quick to deliver these features, then we add this support to the networking ODL, to the drivers, which is just supposed to be like a shim layer connecting Neutron and OpenDaylight. And we talked about the benefits. Let's talk about the problems that we have. So asynchronous, as I said, it's nice and it fits the ODL paradigm, but basically it has drawbacks as well. So we don't have a way to know the state of resource in OpenDaylight, right? Like if I create a port, I don't know if it's really created. I don't know when it's really created. So this is being worked on right now. We have in the works support for port status. So at least we know that the port is up, it's available for use. And this will be implemented in Pike using WebSocket, hopefully. And also the general paradigm of ODL being asynchronous needs to be handled somehow. Like if something fails on OpenDaylight, we don't have any feedback from Neutron. So from Neutron side, everything looks good, everything is peachy. And then on OpenDaylight, all hell broke loose, so we need to handle this. Also, we talked about scale a bit. So it does, we notice it becomes a bottleneck on scale, right? So because we have this DB level locking and we have like the dependencies calculated and everything. So at a large scale, it does slow down a bit. So we're also thinking about how to scale it on a single server, having journal thread work better, and also changing how dependencies are calculated. It's pretty much technical details, but just to allow better scaling of the solution. And obviously, this is a more complex solution, as I said. Like the first solution was very naive. It was very simple, so we didn't have many bugs. Now it's more complex. There's a lot of bookkeeping code in there. So we need to simplify it as much as possible. But that's the general direction, like this journal approach. That's the general direction OpenDaylight is taking right now for the Neutron integration. Now Josh is going to explain about Netvirt itself.
Probably more detail than you want. First, OpenVSwitch is pretty much a Swiss Army knife. You can do a lot of different things with it, and I wanted to show you guys just sort of a little bit about how the networking is implemented. So the first thing I want to talk about is the sort of, I would call this schema inside OVS and how you connect to provider networks to external networks. There are basically two modes that Netvirt supports. One is you can attach your external network directly to the integration bridge. The integration bridge is where the VM ports get connected to. And so you can basically just have your external network be a port on that bridge. The way this is done is there's an OVSDB schema for OpenVSwitch, and if you there's a place in there on the OpenVSwitch table, and the other config column, you can put in a value that says provider mappings, and then the name of the interface and the name of the network. And OVS will then configure all that for you after reading that data out of OVSDB. The other way is, and this is specifically required for especially if somebody wants to manage the bridge for their external networks separately from the integration bridge. So the integration bridge sort of belongs to Neutron and OpenStack. And then I have a separate bridge, which often is called BRX. And so you can attach, and that's attached to the external network. And OVS will, and OpenDaylight will patch that those two bridges together, and it functions just the same. Basically, all this is done for you. There's a little flow diagram here. After OpenVSwitch, this also is the process by which ODL learns about an OpenVSwitch. The OpenVSwitch connects to OpenDaylight, and OpenDaylight pulls all of its tables, it pulls all its data, and then based on that data, it will configure either this or that. We support VLAN and FLAT and VXLAN. All that is handled internally by OpenVSwitch as OpenDaylight programs it to do. Okay, next slide. So this is a little bit about, this is a very, very, very simplified version of what it looks like when you create a Neutron port inside, what it looks like from inside Netvirt when you create a Neutron port. So you have the sort of northbound, the northbound is blue, and that's the create port, or actually it's port create, always noun and then verb, in Neutron, that comes into the OpenDaylight Neutron component. And then on the southbound, more or less concurrently, there is an event coming from OpenFlow saying, hey, there's a new OpenFlow port. So if I've spun up a VM, technically speaking, this happens slightly before the VM actually comes up, but for all intents and purposes, these two things more or less occur at the same time. And both of those events are correlated, and they're correlated through remember that it was all model driven, so it's all correlated through the model. Notice how none of these components talk directly to each other. Everybody talks to the data model, and then the data model talks to the other components. So we were talking about another interesting point here. We were talking about how OpenDaylight is a platform. So it would not be very nice for one component within a platform to take the pipeline, the OpenVSwitch pipeline, and just say, oh, this is mine. I'm going to use table 5 and table 10 and table 15. And then when you write your application, you can, you're in trouble. So there's this component called Genius, which actually started out as really part of the Netvirt project, but then got spun out. And what Genius does is, A, it makes the pipeline incredibly, incredibly, incredibly complex and hard to understand. But if you use its APIs, it allows coexistence of different services within the pipeline. So because of that, Genius is responsible for writing some of the flows to OpenVSwitch, and Netvirt is responsible for writing other flows. So that's essentially what happens. If we look at the blue, so you get the create port event, and then that data is written to the model. The model then triggers an event in Netvirt and says, hey, somebody wrote a port. And he goes, port, I know what to do with that. I'm going to create some OpenFlow flows. And then he creates OpenFlow flows in the model. And then the model says to the OpenFlow plugin, hey, somebody just wrote some flows. You should do something with that, and then those get pushed to the switch. And basically, there's the reverse, the exact same flow, but in the other direction with the OpenFlow port. On the next slide, which Mike and I are very excited about this slide. I think it speaks for itself. This is a modified OpenVSwitch dump of flows. So these are the rules that OpenVSwitch, that get programmed into OpenVSwitch. And this is a picture, and I filtered out the rows that are not changing. And as you can see, the changes there, those are the actual packets flowing through OpenVSwitch. This is very exciting. It's a VM pinging the DHCP server. But one of the things, if you took the time to read this, I'm sure these will all go online at some point, you can see that, Okay, you had me nervous there for a second, but so you can see this is the ingress flow. And this is programmed by Genius, and it basically says something comes in on port 2, so it gets some metadata written, and then it goes to table 17. Table 17, it has a nice round number because it's the most important table. This is called the dispatcher table, and this is what allows multiple services to live together in the pipeline. So if you look at this flow, you can trust me, because I don't want to get into the bit mapping of the metadata, but you can trust me that it came in on port 2, it goes to the dispatcher table, and then it's going to go down here to these guys, the ACL remote, ACL filter, a whole bunch of different implementations of basically Neutron security groups. And then from here, will go back. You can see, where is it? At some point, here, resubmit 17. It goes back into 17. And then from there, we'll go to a whole bunch of these guys, SMAC and DMAC. This is basically the switch implementation. It looks at the MAC addresses and decides which port to spit out the packet on. And then it will go out on port 2 and go to table 220, which is the egress flows. And these are, so 220, 17, 0, The ingress, the egress, and the dispatcher are all programmed by the Genius component. So for instance, there is an SFC project. So you can literally run the SFC project together with Netvirt, and it won't interfere because the flows will get dispatched to the various tables that handle service function chaining, and then it'll go back in to the dispatcher table, and then it will come out to the SMAC and the DMAC and get switched to where it needs to get switched to. Here it is, but not really, because it's gotten worse since then. We used to have 10 tables, and it was in a line. It was funny to see as a diagram because there was really no reason to make a diagram out of it. This is the big 17 thing. I guess since Mike ended the part about the driver, about how there's also some drawbacks, so I think the drawback of this is pretty obvious. It's very, very complex, but it's also very, very flexible. So all these are services. You can see every time there's one of these little arrow icons, that means go back into the dispatcher. So things go into different, they're called services, and then go back to the dispatcher, and eventually make their way down here to go out. But you can add to these. There can be different implementation, different flows that are added to implement different features like service functioning chaining or anything that anybody else wants to do. I think that's all we have. Sure. Yeah. So hardware VTAP is if you want to attach a VXLAN tunnel. It's a termination point for a VXLAN tunnel, to usually I think for top of rack switches. And there are switches that support, it's an OVSDB schema, and you connect with the OVSDB protocol. It's actually a pretty simple thing, and you say, okay, this is termination point, and these are the ports, and this is the other end, and then you have a VXLAN tunnel to it. Yeah, yeah. It's not just they have to support specifically that schema. And somewhere, I'm sure there's a list of the ones that do. Okay, so we're going to throw out hats. We're supposed to throw out hats. And to make it fair, we're going to close our eyes. So
I let you throw
I don't know.
I let you throw that.
Here, I'm going to do it backwards.
That was very...
Oh, that was very bad. Okay. That was very, very late. Okay, backwards. I don't Now you throw far.
Okay. So if you want any more hats, you need to come to work in Reddit.
That's right. Right. We're always hiring.
Okay. Thank you. If you have any more questions.